Hello everybody. Now we're on to one of the harder things, adding and subtracting rational expressions. Just how adding and subtracting regular fractions is more difficult than multiplying and dividing them, same thing goes for the rational expressions. So your rules. For adding, you have a over d plus b over d. When you're adding, they have to have the same denominator, and then you add the tops together. A plus b over d. Subtraction is the same exact deal. So here I'm subtracting two fractions. I have that common denominator, and I subtract the tops. The important thing is you must have a common denominator. So for both of these, both have that common denominator. The bottoms aren't the same, you can't add the tops together. So let's start with a couple easy examples. Okay, here's our first example. So good directions, perform the operation, simplify. It doesn't say solve. This isn't an equation. This is, we're going to try to add two rational expressions, polynomial for polynomial, polynomial for polynomial. And good news, example one, they have the same bottom. So I can just go ahead and automatically do the addition. Add x plus 1 plus 2x minus 3. And then combine up your like terms up top you want to add. So let's say I got x plus 2x gives me 3x's. 1 take away 3 gives me minus 2 over x minus 3. And say, okay, can I simplify this at all? Nothing to take out the top. There's nothing to cancel out. And this guy is done. No big deal. Alright, let's try another one. Okay, here's a subtraction. So I've got 3x plus 5 over x minus 1 minus 2x minus 4 over 2x minus 1. Again, this one's not too terrible, because why is this problem easy? Because we have the common denominator already. So go ahead and throw that on the bottom, and we need to be very, very, very careful. Very careful. Watch out for subtraction. Make sure and distribute that minus sign. You have to subtract off this whole top right expression, not just the first term. Very, very common mistake with subtraction, and a killer one. So here I've got the 3x plus 5. Everybody's going to get this minus sign. So minus 2x, and then it's got to be a plus 4. This is so important. You see all these crazy exclamation marks. That's how significant this error is. Cannot make the distribution mistake. Make sure you subtract off this whole thing, both terms. And then equals, combine with your like terms. I got 3x minus a 2x leaves me with 1x. And I got a 5 plus a 4. It's got to be plus 9, not plus 1. Sure and distribute that minus sign. Divided by 2x minus 1. Anything cancel out here? Nope. We got it. Watch out for subtraction. Big, big mistake. Don't make it. Okay, let's try one where the bottoms aren't the same. Okay, let's look at this one. So again, we're subtracting, but here our bottoms are not the same. So when this happens, the first thing you do is first factor both denominators. So I got the x minus 3, there's nothing to factor there, that's just x minus 3. And x squared plus 5x minus 24. So here a trinomial with leading coefficient of 1, this is going to factor to x plus 8 and x minus 3. Now we need what's called the least common multiple of these two. If they have anything in common, and these both do, they both have an x minus 3. Whatever's in common, you write it once and cross out of both. And then you need what else? Whatever's left. So I have another x plus 8. This is my least common multiple, which is also going to give me the bottom number. This will be the common denominator that we need. Okay, so let's see what we can do. I'm going to make myself some more space here. So I'm going to erase this by an edge. Oh! Okay, so I rewrote this guy and I factored the bottom. So I know my denominator I need is my least common multiple. Rewrite here because I already forgot what it was. It's x minus 3, x plus 8. Okay, this guy is set. This guy has the x plus 3, but it's missing that x plus 8. So that's what I'm going to multiply to the top and the bottom. X plus 8 over x plus 8. You can only multiply to get to that common denominator. Okay, equals. Here we're going to distribute. So I get x squared plus 8x over the x plus 8 and the x minus 3 minus this guy, x plus 1 over x minus 3 over x plus 8. And now we're set. I can do the subtraction. It doesn't matter that I wrote these and it's not in the same order. Remember, it's multiplying. 4 times 5 is the same as 5 times 4. So this common denominator, we've got it. Be careful though. Remember, we're subtracting. So we need to subtract out this whole guy. So now we're set. We have that common denominator. Go ahead and put it on the bottom. I got an x plus 8 and x minus 3. The top first two terms stay the same. I got x squared plus 8x. And here's where we're going to be very careful. We're going to distribute that minus sign. So minus x and a minus 1. So equals, this gives me x squared, combine your like terms up top, plus 7x minus 1. And the bottom, we're going to leave the bottoms here factored, because at the end, maybe the top will factor, and then we can cancel something on the bottom. That would be the simplified part. So leave the bottoms factored. Just make the problem easier. And we got it. Alright, let's look at one more. Alright, here we go. Here's our problem. I've got x over x squared plus 5x plus 6 plus a 7 over x squared plus 2x minus 3. Okay, form the operation and simplify. So automatically we're in trouble because these two bottoms are not the same. So step number 1, take both the bottoms and factor them, and let's find that least common multiple. So I'm going to take x squared plus 5x plus 6. Now I'm going to factor it. So let's see, general trinomial with a leading coefficient of 1, two numbers multiply 6, add to 5, that's going to be x plus 2 and x plus 3. I factored the other bottom, I got x squared plus 2x minus 3. So two numbers multiply to minus 3, add to 2. It's going to be x plus 3 and an x minus 1. Our least common multiple is, do they have anything in common? Yep. X plus 3, so I cross out both, I write it once, and then I need everything left over. So I got x plus 2 and x minus 1. This is what we need to get both of the bottoms to be in order to do the addition. So I'm going to get myself some more space here. So I'm going to rewrite this guy and with the bottoms factor. Okay, by magic, I've rewritten this. So here's the x plus 2, the x plus 3, and x plus 3 and x minus 1. So both the bottoms are now factored. And here's my least common multiple. So this term has the x plus 2 and the x plus 3. What's it missing? It needs the x minus 1. So x minus 1, top and bottom. This guy's got the x plus 3 and the x minus 1. It's missing the x plus 2. It's the top and the bottom. Multiplying to get to that common denominator. Leave the bottoms factored and multiply the top. Be careful, there's lots of distribution in these problems. So here I'm going to get x squared minus x over all this stuff. I got an x minus 1, an x plus 2, an x plus 3. More distribution, my favorite property in the world. Plus 7x plus 14. All over the x plus 3, x minus 1, x plus 2. And here we go. Now I can go ahead and add. So I got x squared minus x. Nothing to distribute because it's plus. So plus 7x plus 14. All over all this nonsense. X minus 1, x plus 2, x plus 3. Remember, leave the bottom factored and then combine like terms up top. X squared plus 6x plus 14 all over x minus 1, x plus 2 and x plus 3. And let's see, does this top factor? So 14, two numbers multiply to 14, add 6. I always check this at the end to see if maybe the top factors, and I can simplify. So 14, that's 2 and 7, that's not going to work. 14 and 1 is not going to work. Top doesn't factor. We got ourselves a nice answer. This problem took so much work that we deserve a smiley face. Alright, that'll do it for this video. See you at the next one.